Welcome to Curie Electronics. Today we are going to solve Ursc 2017 previous year question paper for Technical Assistant Electronics, and this is the part 1. Here we will solve first 30 questions, the next part the remaining questions. And this exam was conducted on 28/2017, and there were 60 questions and 1.5 hour time. If you like these videos, please share with your friends and don't forget to hit the like button. So let's start solving the questions. Battery cells are connected in series too. Means we connect cells in series. A number of cells we can connect it in series. Usually we make series parallel combination. When you connect the batteries in parallel, what happens? The current capacity increases or AH rating increases. When you connect cells in series, so let us consider each are 1.5 volt. 1.5 volt. Now if you connect a voltmeter here, what does it read? It reads 4.5 volt. If the direction of one of this battery changes, what happens? That I explained in another video. You could see that on the I button. So the right answer is to increase the output voltage. Next question. The value of alternating current or voltage that has the same heating effect as a corresponding DC value is known as this all of us know it is the RMS value. Once we know the V peak, V RMS equal to V peak upon root 2 or 0.707 times the V peak. The number of turns in a coil is doubled in the same length and area in the inductance L will. So what is the equation for inductance? Mu A N square upon L. Now what is L dash? L dash means what I am trying to do? I am trying to double the number of turns and the remaining things constant. So mu A 2n whole square upon L. So here if you write, if you simplify, it becomes 4 mu A n square mu A n square upon L. Mu A n square upon L we have, what it is? L. So we can replace it by L, 4 L. So the inductance has increased by 4 times when you double the number of turns. So it is, the answer is quadruple, option B. If a sine wave has a period t equal to 40 microseconds, its frequency is. So we have a sine wave, and what is its frequency? We have to find. But time period he has given. What is time period? Time period he has given us 40 microseconds. 40 microseconds. So what is frequency? F equal to 1 upon t. Which equal to 1 upon what is a t? 40 microseconds. So 40 multiplied by 10 to the power minus 6 second. So 10 to the power minus 6 goes up, it becomes 10 to the power 6 upon 40. Again, how do you simplify? 10 to the power 1, 3, 4, 5, 6, right? Then 6 zeros 40. 1 0 0 cancels, which equals, now we have to divide this by 4. So 10 divided by 4, 2 times, remainder 2, 5. How many zeros? 3 zeros left. So this is equal to 25,000 hertz. If you want kilohertz, divide by 1000. So it becomes 25 kilohertz. 25 kilohertz. If you like these videos, please share with your friends and don't forget to hit the like button. Let's continue the questions. Question number 5. Let me take the right, no, I not take the right answer. It is 25 kilohertz. Question number 5. A capacitor that can store 100 microcoulomb of charge with 10 volts across its plate has a capacitance value of. So Q equals CV. What we want to find? We want to find the C. So C equal to Q upon V. So C equals, what is the Q value he has given? 100 microcoulomb. 100 multiplied by 10 to the power minus 6 upon 10 volt. So it becomes 10 to the power minus 5. 10 to the power minus 5. Now 10 volt. This 10 to the power minus 5, we have to write it in microfarad. So what I do? I will multiply and divide by 10. Then what happens? Multiply and divide by 10. Then what we have? 10 to the power minus 5. Now 10 multiplied by this 10 to the power 10 comes, this is equal to 10 to the power 1. When I take it on the numerator, it becomes 10 to the power minus 6. So it is, the answer is 10 microfarad. 10 microfarad is the right answer. How much resistance must be connected in parallel with a 360 ohm resistor to obtain an equivalent resistance of 120 ohm? Equivalent resistance of 120 ohm. So we have a, what is there? We have a 360 ohm resistor and we have to find the value of what is the other resistance. Let it be R1. Now R2 we don't know, but the equivalent resistance we know. What is the value? RT equal to R equivalent equal to 120 ohm. Now we can write RT equals a parallel combination. R1 R2 upon R1 plus R2. R1 R2 360 multiplied by R2 we don't know equal to R1 360 plus R2. We have to find the value of R2. RT we know. RT, I will put the RT value. So RT is 360. No, RT is 120, right? 120 equals 360 R2 upon 360 plus R2. Now simply what I can do, 120 is there on the left hand side and right side 360. We can divide this complete thing by 120. Or we can, so what happens? Here 1 will be there, here 3. Now I will cross multiply. Okay. Now what do we get? 360 R2, 360 plus R2 equals 3R2. 3R2. Now 360 equals R2, I will take it right side. So then what happened? This is 3R2 minus R2. So 360 equals 2R2. Now you can easily write what is R2. R2 equal to 360 upon 2. So you'll get 180 ohm. So we got the answer as 180 ohm. So if we connect 180 ohm and 360 ohm, you will get an equivalent value of 120. Next, a differential amplifier has a differential gain AD of 100 and common mode gain AC of 0.1. What is CMR? If you see, the answers are given in dB. So CMR in dB equals 20 log, it's a voltage, so we have to take 20 log differential gain upon common mode gain. Common mode, you should get a common gain is assumed to be, in ideal case it should be 0. So 20 log, what is AD? AD equal to 100 upon what is AC? 0.1, which equals 20 log, numerator and denominator I'll multiply by 10, then you'll get 1001, which is equal to 20. This is a log to the base 10. Okay, so what is log of 1000? Equal to 3. So you get 60 dB. 60 dB. So 60 dB is the right answer. Question number 8. What is the modulation index in a frequency modulated signal with a modulating frequency of 500 Hz and frequency deviation of 10 kHz? So it's a FM question, frequency modulation question. There modulation index M equal to deviation in frequency delta F upon modulating frequency FM. So what is the deviation? That is 10 kHz. So we can write it as 10 multiplied by 10 to the power 3 upon what is the modulating signal frequency? 500 Hz. So 1, 2, 3 upon 500. See what you will get? You will get 20. So 20 is the right answer. Option B is the right answer. Notch filter is, this notch filter is known as band stop filter. It will pass all the frequencies, okay, but a particular band of frequencies it doesn't pass. So it's a band stop filter. If you see the response curve of this, it is going to be like this. Frequency, amplitude. So it will pass all the frequency, but a particular band of frequencies it doesn't pass. This is going to be the notch filter or band stop filter. Question number 10. To double the resonant frequency of an LC circuit with a fixed value of L, the capacitance must be. So let's take the angular frequency omega of the LC circuit, that is equal to 1 upon root LC. Now what is telling? We have to find the omega dash. We have to double the frequency, resonant frequency. That is omega, this is omega r, okay, omega r dash. So what we do? We'll write the same equation. So here if you observe, to increase the frequency, you have to decrease the capacitance because L is going to be same. So we need a square term actually. So I will assume that it is reduced by 1/4, that is 1/4 of the actual capacitance. So I'll write C upon 4. 4 times I am decreasing the capacitance value. And now omega r dash equals 1 upon square root. If we apply, LC will come just as the previous one. Then what we get? What is square root of 1 by 4? That is 1 upon 2, which equals 1 upon root LC upon 2. I'll write it on the left side here, right side I'll here, top. So omega r dash, that's a new resonance frequency, equals 2 upon root LC. Now 1 upon root LC we know, that is omega r dash equals 2 times omega r. So we got the equivalent equation. So what is the answer? The answer is reduced by 1/4. What is the barrier potential of a silicon diode at room temperature? It is 0.7 volt. Which diode is used as a voltage regulator? We know it is the Zener diode. What is the specialty of this tunnel diode? It is the heavily doped diode. Heavily doped diode. This pin diode is made up of intrinsic semiconductors as well as p-type semiconductor. Question number 13. The main advantage of CMOS is it is a low power consumption. Low power consumption is the main advantage of CMOS. Silicon control rectifier is usually turned on by. How will turn on? We have the silicon control rectifier. So this is the anode, cathode and gate. By applying the gate trigger, we usually turn on the SER. See, this SER can be replaced with a, we can say it is a PNPN device. PNPN device. And this is the anode, cathode and gate. So it has got how many junctions? J1, J2, J3. So 4-layer 3-junction device. Sphygmomanometer is used for checking blood pressure. Ultra diagnostic imaging typically employs a frequency range from. The ultra diagnostic if you want to see our intestine, or the best example is whenever a woman is pregnant, to see the baby they use this ultrasonic imaging technique, and the frequency used for this is 1 megahertz to 15 megahertz. Persistence of vision in a human eye is. See, persistence of vision means we can take the example of a LED. If you make continuously LED on and off 16 times in 1 second, 16 times in 1 second, okay, second, our eye won't be able to identify whether it is on or off. So that is called the persistence of vision. So it is 1 by 16th of a second, 1 by 16th of a second. In the TV and all, we use 1 by 25 frames in 1 second. Question number 18. Transconductance in a FET indicates how effectively the input voltage controls the drain current, that is the output current. Aspect ratio for HDTV, high definition TV. What is the aspect ratio? It is high, that is 16:9. This 4 is for standard TV, standard definition TV, 4:3. So for high definition TV it is 16:9. Compared to a silicon rectifier diode, an LED has LED has higher forward voltage drop. That means some LEDs require 3 volt to turn on. But this LED can't withstand higher reverse voltage. So the right answer is option D, higher forward voltage and lower breakdown voltage. Which phenomenon is best explained by the particle nature of light? That is the photoelectric effect. Photoelectric effect, what it says, when light falls on a photoelectric material, electrons are emitted from it. That can be explained best with the particle nature of light. But the diffraction, Doppler effect, polarization, these all are based on the wave nature of light. Energy of a photon varies directly with what? It is directly varies with the H is equal to with the frequency. The energy of a photon increases as frequency increases. What was the equation for it? It is, I forgot, let me check. Okay, E. Energy of the photon is given by h mu. Mu is the frequency. So frequency increases, the energy of the photon also increases. Now next question. Question number 23. Norton theorem states that an entire network connected to a pair of terminals can be replaced with what? As per the Norton theorem, any circuit, any linear bilateral circuit, we can replace with a number of sources and resistors. We can replace with a single current source. This shows a current source with a parallel resistor. This resistor is known as the Rn, Norton resistance, and this is the In, Norton current. And there is one more theorem, that is Thevenin. As per the Thevenin, any circuit we can replace in a bilateral linear network, we can replace with a Thevenin voltage, that is VTH, in series with a resistance RTH. This is the Thevenin. This is Norton, and this is Thevenin. So what is the right answer here? Option B, a single current source in parallel with a single resistance. If the error in the measurement of a radius of a sphere is 1%, then the error in the measurement in its volume. This is related to errors. Let me try to solve it. See, volume of a sphere. What is volume of a sphere? Volume of a sphere, V equal to 4 by 3 pi r cube. Here he is telling the resistance radius measurement, that is R upon delta R. That is delta R upon R equal to, has given us 1%. Delta R upon R. V equal to 4 upon 3 pi r cube. Now let's try to differentiate this. Then what we get with respect to R, dV upon dr equal to 4 by 3 pi 3 r square. Now what I'll do, I'll write again dV upon dr equals to 4 by 3 pi 3. I'll multiply and divide by r, so I'll get r cube upon r. I'll get r cube upon r. How can we write this? This is equal to, now I will consider like this, delta V upon delta R equals 4 by 3 pi r cube. That is, see, I'll write once more, I'll write it 4 by 3 pi r cube. Then what I have? I have 3 upon r I have. Now this I will write it as V, that is the original V. I'll write here top. So delta V upon delta R equals V, that is the actual volume. I am just manipulating to put the value of delta R by R upon R I have. Now I'll write delta V upon delta R equal, delta R upon delta V. That's what we want. Delta V, not delta V, that is V. We are cross multiplying. Okay. V equals delta R upon R. But something I forgot to write. That is 3 is there. 3. Correct. Is 3. So now we know delta V upon V equals error in the volume. What is delta R upon R? That is, he has given us 1%. So what is the measurement error in its volume? That is 3%. 3% is the measurement error in the volume. Question number 25. The phenomenon of some of the higher frequencies in the spectrum of the signal GT appearing as low frequencies in the spectrum of its sampled version, that is the aliasing. Question number 26. Error detection and correction is done. To detect the error and correct it, we send some redundancy bits. That means after receiving it, we need not to consider those redundancy bits. So it is done by adding redundancy bits. A real signal is said to be even. See, we have a signal of g of t. If we do the time reversal, that is g of, this is equal to time reversed signal, that is g of minus t, then it is known as the even signal. Even signal. Even signal. So g of t, if we get g of t equal to time reversed signal g of t, then it is even signal. Or the graphically we can show it as this is the amplitude and this is the time. We have a signal like this, 1 minus 1. See, these two signals are mirror image of the first and second quadrant. It's a mirror image. These signals are the even signals. The difference between any one measured value and the arithmetic mean of a series of measurements is termed as. It's not accuracy. Accuracy means when you measure a number of times, we should get the same value or closer value. That is the accuracy. And not accuracy, precision. That is precision. Okay. Accuracy means it is near to the original value. Actually, the measuring value should be true value. That is the accuracy. And resolution. So these three we can avoid. So this answer is going to be deviation. Deviation. Question number 29. The correct sequence of PCM modulation is pulse code modulation. What do you do? First you have to sample the signal. After sampling, you will quantize the signal. Then you will encode. So first sampling, so the answer is option C. First you have to sample it, then you have to quantize a signal. Quantize means we are converting it into discrete levels. Then you can encode it. So this is the proper sequence of PCM modulation. This is the last question for today. Resolution bandwidth of a spectrum analyzer is its capability. The spectrum analyzer we use to get the information regarding the frequency. Usually the x-axis there will be a frequency and the y-axis this will be power in dB. This question, resolution bandwidth of a spectrum analyzer is its capability to resolve smallest frequency separation. So to study the frequency only we use this spectrum analyzer, and what is the power of that particular frequency, what is the power of that signal. So answer is to resolve the smallest signal frequency separation. So we have completed the first part. I hope these are useful to you. If so, please share with your friends and don't forget to hit the like button. And thanks for watching.